Besides the aforementioned components, two important issues in the operating system need to be considered: protection and security. So in order to make the operating system more safe and stable, the operating system provides protection and security two features. For the protection, the operating system controls access of processes or users to resources which defined by the operating system. For example, when a process wants to access a data or memory or certain part of the hard disk, and the operating system will check so whether the process has the right to do so, or when a user wants to delete a file, so whether the user has the right to do it or not. For a security issue, the operating system provides the defense of a system against the internal and external attacks. So as we know, nowadays there are a lot of attacks. So they try to crash or hack our operating system. For example, some virus they sneak into our computer. So at some point, it may just burst out and delete some critical files, then crash our system. Or some worms, they infect our operating system from the internet because you just carelessly open some malicious email. Then the worms may record your bank account and the password and send them back to the hackers. So later, the hackers will log in your bank account and steal your money from there. So there are so many protection and security issues needed to be handled by the operating system. And one task of operating system is to address those issues. It requires a system to be able to distinguish among users to determine who can do what. And the operating system needed to maintain a lot of critical information. For example, the operating system will maintain the user identities, or sometimes we call it user IDs, protect user identities through the password. So according to the user identities, the operating system will decide so which user has the right to access which files and which processes. And also, the operating system will define group identifier or group ID to grant a different group of users with different set of operations. So for normal group users, the user can only do standard operations such as using some normal software, store some files, or do some standard settings. On the other hand, there is a group of users as a system administrators. So for those users, they have a higher privilege to operate the operating systems. For example, they can install some software and update the operating system or even delete other users' files. However, sometimes for some normal users, they may need to do some operations which requires a higher right. For example, the normal users, they want to update some software such as Microsoft Office. Therefore, the user needed to be temporarily assigned higher right to do that, right? So actually, they can do it through privilege escalation, so which allows user to be changed to effective ID with more rights. So later, they can give up the higher right and then go back to the normal user group. Inside the operating system, especially inside the kernel, it needs a lot of data structures. So the only difference between the standard data structure and the kernel data structure is the kernel data structure must be carefully implemented to ensure the efficiency and to maximize the efficiency, and also to minimize the possible bugs. So you can imagine if the bugs exist inside the kernel data structure, so when the bug happens, it can crash the entire operating system. So I'm not sure how many of you guys use Windows operating system. So especially for the previous versions. So there's a term called blue screen. It means the Windows is crashed. So you need to restart your system. And here lists the numbers of data structure. So I bet most of the data structures you already learned from your data structure course or algorithm course. So many of the kernel data structures are very similar to the standard data structures. Again, the only difference is they must be implemented very efficient and bug-free. So for example, the linked list data structure, which is implemented through pointer. So since all the programming assignment are required to be implemented with the C programming language in this course, so later you will implement the linked list in your programming assignment. So first, let's see the linked list, the singly linked list. So for each element, there are two parts. One part is for the value. Another part is the pointer, which point to the next element. So the pointer will point it to the next element. And for the doubly linked list, for each element, there are three components. One is for the value, the other two is for the pointer. And the one pointer will point to the next element, and the other pointer will point to the previous element. And also we have a circular array. For the circular array, the last element will point to the first one. For the stack, so most of you should know that last in, first out. So you will push the data on the top of the stack, then pop up the value from the top of the stack. And for the queue is first in, first out. So in queue means you can add the value from the end of the queue. And the dequeue means you can get the value from the head of the queue. And for the tree, is the widely used data structure, especially for the binary search tree. And also, we have hash functions and the bitmap. So if you are not very familiar for some of them, you may need to review your course material of data structure. And also, you can check them online. So if you still have questions, feel free to ask me. Again, although those data structures are pretty similar to the standard data structure, so they need to be implemented very carefully to make them very efficient and bug-free. So for this sentence, I already claimed for 3 times, so you will know that it's very important. So in Linux system, the kernel data structures are defined in the Linux kernel. So later, when you install the virtual machine, which I will provide it to you, so you will know that those kernel data structures are defined in the include files. So for example, the linked list is defined in the Linux list.h, and the queue is defined in the Linux k50.h. And this header file, Linux rb3.h, is for the special implementation of binary tree.